Hello, my name is Garrett Coleman. Thank you for joining us today. I'm going to go over our Fab and Fill product line. A general overview of Fab and Fill product line. What this is a metal skeleton that has rigid layers on either side that would then be filled with a high performance biosilicate material that would provide insulative properties, thus creating a durable, high performance structure that would be able to withstand most weather situations, pests, and fire. The way this came about was we were looking at building interior panels for pre-modular interior panels for concrete walls. So then we had the idea of, well, if we're just doing pre-modular interior panels for walls, why couldn't we add an external layer on the outside and go ahead and create a wall in itself and not have a panel on it? But there was some guidelines that we wanted to go by. We wanted to look at it from the customer's needs, and also from a manufacturer standpoint. But on the customer side, we wanted something that the customer could pay for, that would be cheap, consistent quality, the cost of ownership would be down, the cost of maintenance would be drastically decreased, and they would have a home that would truly last them a generation. On the manufacturer side, we wanted to take work off of the job site, put it in a more controlled environment, and try to accomplish as much as possible before the wall section arrived on the job site. And I think we've done just that. And what you're seeing here on this piece of paper is a stack up of building materials. This right here is the prototype design. There are some other innovations that would be included in the actual manufacturing process, and I'll discuss those with you here in just a moment. So the idea would be to build these walls in 12, 8, and 4-foot sections. That's what most building material comes in, and that would be easy for us to have general contractors finish out the interior of the homes. This also allows us to build the home in any configuration that you want, as long as it is on values of 4. So what I mean by that is I could actually do a inset porch that is 8 foot by 8 foot by building the panels in that way. The way we wanted to take all the work off of the job site was we wanted to pre-run all of our electric and water inside the walls prior to it even leaving the factory. How we've accomplished this, if you look in the middle of the paper, there is a corner piece. It is labeled corner, water, and electric. This would be where your main supply would come in from the bottom of the corner through the slab, run into your main electrical panel or your water manifold, and then run a conduit vertically up and across the wall section, and then vertically down to your electrical outlet or plug. What this allows is for cost of maintenance is way down. How we're doing this is running this as conduit inside of conduit, and each specific line would have each specific run. So if a pipe busted, I could disconnect it from the spigot, open my corner up, remove that pipe, install another pipe, and it's fixed in a matter of minutes. Going from interior to exterior, we have an interior drywall, which is regular sheetrock. We have a rigid foam layer. This foam layer has an R value of 9, and I believe it was 3/4 inches thick, and it's readily available foam insulation that would go on the interior of the wall. The next is plywood. What this plywood does is fastens to the metal skeleton, thus allowing us to pour and seal the biosilicate material inside of the metal skeleton. The next rigid layer that you see on the other side of the metal skeleton it's a little bit different on the way it's fashioned. The way it's fastened on there is it has a 1.5 to 2 inch gap on the back side, or on the exterior of the wall, for 2 reasons. One, we don't want any metal exposed to the exterior of the structure, because this would over time cause rust spots and deterioration of that metal material from weather and other things. Another thing that this does is it provides a mold. This mold would give us any elevation we want. Elevation meaning if I wanted brick, stacked stone, stucco. Honestly, it is infinite on whatever you want. In the prototype design, we used plywood to create this mold. That is the reason why you see the metal skeleton on the exterior. With the weight of the concrete and the cementitious material that was inside of the structure, we had to reinforce the exterior so to prevent any blowouts or anything else. Hello. So now I'm going to go over the model sample wall that we have created for the prototype to show some of the features that we were discussing earlier. As you see here, this is my corner piece. This would be the cornerstone that houses everything. The walls bolt up on a flange system. So the wall would come up and connect with the flange. You would then bolt it together, and the cementitious material, or the flange would be designed where the cementitious material can go through and allow everything to lock in together. Let's say we're going to build them in 12, 8, and 4 foot sections. What I'm about to show to you here is the exterior. So this was the one that I explained earlier that said was sitting off an inch to or inch and a half to 2 inches on the exterior, thus allowing for the mold and then not putting any metal on the exterior. So what we did, we had this all set up, we poured the material, we let it cure, and then we removed the mold. Thus revealing what the elevation that was desired underneath. This right here is just regular stone. But as you can see, it gives it definition and is a true solid wall all the way through. The way we plan on doing this in manufacturing is not with plywood, but with HDPE, which is high density polyethylene. It's a very rigid plastic. It holds tolerances and is millable to spec. So we can do whatever type of design that we wanted back here on the back. Now as you see, this does show a window. So there would be frames within inside of our metal skeleton that would house the window frame. Windows would be installed after the pour, after the cure. Another innovation that we have come up with, since it is a frame within inside of a frame, is that in case there is a bad storm coming or of flooding, this would be able to be removed, and we could actually install a block out that went on here that would prevent flooding on the interior of your home whenever the water level did rise. On your corners, you can kind of see, remember I said everything runs into your corners. So my electrical panel or my electricity would come in from the bottom and then run up vertically over and then down into the structure. There is electric line running inside of this conduit, as well as your water supply running inside of a conduit that goes down to the spigot. Alright, now we're going to go over the interior side of the sample wall. We're going to start out at the corner. As you can see over here, this is where another flange section would bolt in for a wall going out this way. What this access panel is right here for is an interior access to your exterior access. The reason why this is designed this way is for security. Remember, from the bottom, you're going to have your main supply of electricity and plumbing coming in. What this panel would do would then allow you to access the exterior access panel and then access your electrical panel or your water manifold, which then also gives you access to all your conduit piping for whatever utilities that you would be running. As you see, everything is completely finished on the interior. It's ready for paint or anything else. We have a sheetrock. the electricity was already run and plumbed in. Wires were not pulled until after the pour. What you have is a conduit coming down to a masonry box, and then all the finished stuff is done after the pour. So the electricity, as you see, runs up here and then down into your electrical panel. The same thing with the water. The water would run straight down into a sealed panel, which the reason why it's sealed, in case a water pipe busts on the interior, this would make it where you do not flood on the interior of your home. Another way, a little innovation that we thought about was how could we decrease the amount of wires run back and forth throughout the house? So we come up with using Bluetooth switches. So as you see, this switch has no wires connected to it, and it connects wirelessly to our light socket. So, and then another innovation that we're looking at using is using indium tin oxide, which is then sandwiched in between a polycarbonate transparent material. And what this stuff does is whenever a small electrical current is given to it, it frosts over. So as you see here, this just changed from transparent to non-transparent. We think that one, this will provide security and privacy. Two, it will block out UV radiation from the exterior. So on these homes, we're looking at trying to be the most efficient as possible. So if we can frost out, still get ambient lighting in, but lock out some of the UV radiation, it will keep the interior of the home very cool. All right, and this is our prototype wall. After we have looked at and built a couple of versions of the smaller walls, we said, okay, let's build a 400 square foot prototype wall, and this is what you're seeing here. So this is one of the corners. As you see, there's a wall section bolted to this corner, as well as over here. This is the exterior of the structure, so the metal skeleton that I was explaining to you going over the PowerPoint slide is what you see right here. So after this is poured and everything's cured, you would pull these bolts and this whole exterior skeleton comes off, thus revealing your elevation on the interior. These walls are 10 by 10. The corner sections are 10 foot tall. All right, so what you're seeing here is the interior skeleton of the whole wall. As you see, we have two pieces of flat bar that are run in between studs with spacers. It was designed this way for the prototype design, just for ease of material. What we're looking at and what I've developed is a solid piece of material that would go all the way through the whole thickness of the wall, and then would have pieces that snap on. So in the manufacturing process, all the welding and everything that this prototype design required would not be required on the other. So it would be a lot faster and honestly would be just as stronger than what we have here. As we go down through the interior wall, my bolts are run all the way through from interior to exterior. So this is not going to allow for any type of blowout on our forms. So we're trying to make sure that any chance of mishap is mitigated. As you see down here, this would be my corner element. The reason why there is a space between the corner element and this over here is, remember, we still got to come out with our foam and then our insulation for our finished wall design, and that would put it pretty much flush with the corner, thus still allowing a spot for your interior access panel. Again, these walls are 10 by 10, so two 10 by 10 sections would bolt together. There's 8 walls total, and that would give us a total of 400 square foot. Thank you.